I dah start record. So let's masuk on polar covalent bond. You guys boleh nampak kan? And kalau if any question terus cakap because saya takut nanti saya tak nampak korang. Okay, so today kita akan belajar pasal polar covalent bond. And why is it important kita nak belajar? Because in the future, by having a polar and non-polar punya molecules, you guys boleh actually use, it's called a TLC method. So kita ada like a piece of white paper covered in calcium carbonate, and what you do is you letak sample of you punya control and sample yang you dah buat. Okay, you letak garis, and then what you do is you dipkan dia dalam a polar punya solution. So apa maksud dengan polar? Maksudnya you punya molecule have a net dipole moment. Apa tu net dipole moment? Kita akan tengok nanti. It is basically you punya molecule ada charge. So polar punya molecule usually repel each other. So dia orang menolak. So bila you masukkan ke dalam this solution, you akan nampak dia akan bergerak. This dot akan bergerak ke atas. So this is one qualitative way untuk observe that you dah buat you punya sample lah. Contoh you nak buat apa-apa yang polar. Okay, so what is a polarized bond? Siapa ni masuk ni? Nak masuk. Okay, what is a polarized bond? Okay, the very simple thing, polarized bond maksudnya satu atom is electronegative, satu lagi electropositive. That's it. Okay, maksudnya kalau you guys tengok ada yang the one I give you the periodic table yang with electronegativity values. Don't worry, dalam exam you guys takkan diberilah the periodic table. Tapi what you will be given is a table of electronegativity values. Dia akan bagi elements dekat sini and then electronegativity kat sini. So dia akan bagi situ. Macam itulah. So don't worry. So polarized bond maksudnya one atom dengan the other atom, dia orang punya electronegativity values banyak sangat berbeza. Kalau fluorine is 4 and carbon is around 2.55. So berbeza, almost double. It means it is a polarized bond. Apa tu maksud polarized bond? Okay, kalau if you remember, electronegativity maksudnya this atom is very electronegative. Maksudnya dia suka sangat nak tarik elektron kat dia. It's very electronegative. Dia suka sangat elektron. Okay, electronegative is like suka elektron. So in this bond, contoh in CF punya bond, diorang ni covalent bond kan. Diorang share elektron ni. Dia ada satu elektron sini, satu elektron sini. Diorang share. Tapi since fluorine ni suka sangat elektron, so actually cloud of electron tu dia bentuk macam ni actually. Di mana most of the electron dia bergerak ke arah fluorine. Okay, so that's why it is called polarized bond. It's very polar. Okay, and as you know, electron charge dia negatif. So kalaulah banyak negative charge dekat sini, maksudnya dia dah ada a net dipole moment. Nanti kita akan tengok what is net dipole moment. Okay, di mana bentuk plus ni kita always buat dekat the more electropositive, electronegativity value yang rendah, and arrow menunjukkan arah di mana yang electronegativity lagi tinggi. Okay, this is about a polar molecule. So we have a negative and positive pole. Okay, so a positive pole kita tandakan dengan positif. So it's just an arrow, and you letak positif dekat bahagian atom yang elektropositif lah. Okay, so dia punya electronegativity kita also can letakkan, kita can also denote it dekat each of atom. So cara nak lukis is this. It's called sigma plus, and cara lukis dia is mana? So cara lukis dia macam korang nak buat 6 tapi korang mabuk. So dia macam itu tak apa. Ataupun kalau macam ni, most of the time orang tulis ni lah. So ini pun terima, ini pun terima, but most of the time kita akan tulis like this. So you nak buat 6 tapi you lupa macam mana 6 terbentuk. Okay, and then charge dia penting. So kalau value dia rendah, okay, which is you letak plus, and value dia tinggi is negative. Alright, kalau macam oksigen ni is 3 point something, so it's very high. Okay, electronegativity value yang paling tinggi, the highest one is 4 paling tinggi, which is fluorine. Okay, just know that. Kalau you nampak fluorine, 100% dia the most electronegative. Okay, so a polar molecules like this, contoh HF, macam tadi saya cerita, fluorine is very electron rich. Dia suka sangat elektron, so dia tarik dekat dia. So having dekat hydrogen ni is less electron. So hydrogen jadi electropositive sikit, while fluorine is more electronegative. So what is a dipole moment? Dipole moment, okay, dipole maksudnya dua pole. Okay, dipole moment ni is kita nak bagi tahu maksudnya, okay, bayangkan magnet kan, kita north dengan south, maksudnya kita ada dua pole kan, pole yang north, pole dengan south. Same as molecule, dia ada belah elektronegatif, belah yang elektropositif. So dipole moment, usually kita akan tengok net dipole moment. What is a net dipole moment? Is dipole moment yang kita tambah semua. It is a vector lah, kalau you guys ingat dalam physics. This is one type of vector lah. So a polar molecules has dipole moment is not equal 0. Okay, non-polar, okay, maksudnya dia tak ada polarity. Kalau ada another charge punya molekul, dia takkan affected, dia punya dipole moment is 0. Maksudnya kalau dipole moment tu more than 0, dia adalah polar. So simbol as cross saya dah cerita tadi, more electropositive kita letak plus dekat atas dia, and arrow tu ke arah electronegative. Right, siapa baru masuk ni? Okay, so just know, sometimes they don't give the value of dipole moment. Kalau dia give a value contoh 3, you dah tahu dah kan, dia punya it is a polar kan. Just tu je. So don't worry, the number will not complicate stuff. Just know that kalau ada number, it is polar. Kalau dia 0, it is non-polar. Itu je. Alright. So okay, faham semua? The arrow should be, so macam ni a bit salah tau, this arrow. You should have the arrow is positive dekat bahagian positif, and arrow ke arah yang negatif. Like that. Okay. What about molecule? Okay, contoh macam ni. Tadi kita tengok only for dua kan. Okay, dua je atom. So it has a net dipole moment. Okay, contoh kalau carbon dioxide, okay, carbon dengan oxygen has a polar bond. Okay, carbon dengan oxygen is a polar bond. Tapi kenapa dia ada zero net polarity? Sebabnya, okay, we have a dipole moment daripada carbon ke oksigen, and also sebabkan dia adalah linear, okay, dia adalah linear, we also have another dipole moment ke arah bertentangan ke oksigen lagi satu. This dipole moment, since saya cakap tadi vector, dia ada direction, so it can cancel out each other. So this dipole moment, they cancel out each other, having a zero net polarity, which is a no net dipole moment. Zero net dipole moment. So kalau lah kita tengok carbon dioxide, kita letak dia dalam a solution. Contohnya kita sejukkan gas carbon dioxide sampai dia jadi liquid, and kita check dia punya polarity using yang tadi saya cakap macam kertas tu, we will find out that dia takkan bergerak sebab dia adalah non-polar molecule. Okay. Contoh macam this is a bit hard untuk visualize. A tetrahedral. Kenapa dia have a zero net polarity? So mana my tetrahedral ni? So tetrahedral, boleh nampak ke my screen? Kalau you guys boleh tengok my screen. Haya, masuk lambat masuk cepat sikit. Okay. So kenapa it is a non-polar molecule? Even though kalau you guys tengok, it should not cancel out each other kan. But remember, all this ada angles, and kalau you remember you kira vectors, you kira angles kan. Ada dua yang you akan kira kan, x dengan y. Okay, tak apa, masuk. So kalau you guys kira betul-betul, saya dah malas nak kira because saya tak suka physics. So you kira semua, all of these vectors akan cancel out each other. Contohlah, this is carbon, this is fluorine. This akan cancel out each other. Even though you guys nampak they actually not cancelling out kan. But kalau you kira all the angles, 109.52, it cancel out each other. So let's go back to our side. Okay. Covalent bond between same atoms. Sekejap. Let me see mana. Okay. So, covalent bonds between atoms. So, fluorine is very electronegative. Okay, contoh kalau both of the atoms are the same. Fluorine are electronegative. The other fluorine pun is the most electronegative atom lah, basically. So fluorine and fluorine, adakah ia polar? Okay, kenapa it is non-polar? Because fluorine 1 and fluorine 2 tarik the electron dekat tengah ni with the same force. So actually this bond tak polar pun. Electron dia are distributed equally in each atom. Samalah OO, OOO, NN. Okay, anything yang sama, it is non-polar. Alright? So, it's only polar kalau first it is different atom and one is electronegative and one is more electropositive. Okay, that's the first thing. And then kita akan tengok dia punya shape lah. Kalau shape dia cancel each other, it is electropositive. Okay, one example of a polar bond. Okay, mana mereka sebut? So H2O. Okay, kalau you lukis Lewis structure dia, and then you tengok dia punya molecular shape, alright, it is oxygen, hydrogen, lone pair, and lone pair. Alright. So for this molecule, is it polar ke tak polar? Tolong cakap. Polar or non-polar? Tak apa, jangan risau salah ke betul. We learn together. So is it polar or non-polar? Adakah polar? Yes. Okay. Kenapa dia polar? Okay. Kalau you guys tengok, we have hydrogen and oxygen. Oxygen is very electronegative and hydrogen is very electropositive. So let me show you like this lah. So without the lone pairs. So untuk draw dia punya arrow, so we have a positive punya, the more electropositive punya atom, the electrons are pulled towards the oxygen. Same here. Alright, thus we are having a net dipole moment. Okay, kalau vector, sebab ingatkan this is vector, so the net dipole moment is pulling upwards. So most of the electrons are here dekat oxygen, so it is a polar punya molecules. Alright, so we dah habis about polarity. Right, and now kita akan masuk hybridisation. We need to explain why. Kalau you guys remember, we punya bond, kita punya bond only resolve around valence electron. Tapi kenapa some of it, even though valence the electron dia sikit, dia boleh buat banyak bond. So salah ni. So here, chapter 4.3 overview, kita nak tengok pasal sigma and pi bond, dekat mana dia orang overlap, and then hybridisation. Okay, so first kita tengok dulu sigma and pi bond, macam mana dia orang overlap. So in covalent bond, okay, is a valence bond theory. Dia orang cerita that untuk have a bond, those orbital need to overlap. Okay, so and then dia ceritalah untuk sigma bond, which is a single bond. Okay, sigma is single bond, and pi bond is double or triple bond lah, double or triple. Okay, so it explain lah macam mana this bonding occurs. Okay, sebabkan dia orang share kan, remember covalent, dia orang share, dia orang tak bagi electrons tu, dia orang still pegang. So how actually those electrons are being shared? Okay, untuk sigma cakap it is shared bila electrons ni overlap macam kepala ke kepala lah. Contohnya dia macam kepala, dia macam terhantuk kepala dia macam ni. While pi bond is side to side. Okay, and one thing is, untuk sigma bond, this bond can rotate, while pi bond dia cakap restrict rotation. What does it mean? Okay, so tengok my camera. So take a look at my camera. Look at my handsome face ni. Saya nak tunjuk my models. Okay, so bayangkan we have two atoms. So oxygen lah, bayangkan this is oxygen, and atas ni is dia punya orbital. Okay, so this is oxygen, this is orbital lah. Okay, bukan other molecules. So bayangkan this is dia punya orbitals. So oxygen, kalau you remember, dia ada, tak nak lah oxygen, saya nak nitrogen. So nitrogen boleh buat triple bonds. Okay, nitrogen boleh buat triple bonds. Macam mana dia boleh buat 3 bonds? Okay, doesn't make sense nak sambung ni 3 way, right? So how nitrogen make a triple bond? Okay, the very first bond, the sigma bond, is the overlap between the p orbitals. So dia overlap macam ni lah. So bayangkan dia bersambung like that. That is the first bond, the very first sigma bond. So okay, bayangkan dia dah overlap sini. So that is the sigma bond. Okay, macam ni. So, and then how does they buat the double bond, the first pi bond? Okay, the very first pi bond is, kalau you guys tengok, the more dia datang, this orbital sekarang dah boleh overlap. Alright, orbital kat atas ni. Okay, the other p orbitals. Kalau you guys remember, p orbitals we have pz, px, and py. So we have 3, right? So the first dah overlap, right? Now alright, so it is already overlap. And now kalau you guys tengok, these orbitals are very close to each other. So the first pi bond is the overlap between these two, right? So the overlap is just, kalau you guys tengok slide tu, this side to side. So that is a pi bond. Okay, this is the overlap. Doesn't mean this is the second pi bond. No, this is the same orbital kan. So kalau pz, atas dan bawah. So this 2 is the first pi bond. Mana is the third pi bond? Which is, no, the second pi bond. Sorry, sebab kita ada triple bond kan. The triple bond, which is the second pi bond, is this orbital. Okay, kalau contohlah, I cakap this is px and this is py. So pz dah double bond and this is the triple bond. The bond is side to side. Right? So that how they are bond. Yes. The only difference yang you guys kena ingat is a sigma bond. Sigma is must be head on. Must be head on. Heads on. And then pi bond dia side to side punya overlap. Dia overlap side to side. So okay. Now let's tengok dekat my slide balik. Right. Aduh. So let's look on CH4. Okay. CH4. Macam mana dia boleh actually buat dia punya bond? Kalau kita buat Lewis structure, kita buat molecular shape dia, you should dapat it is a tetrahedral lah. So it is like this, this, and this. Okay, fair enough. Kita dah kira dia punya valence electron semua, and it should get tetrahedral. But we actually have a problem. Okay, so hydrogen. So hydrogen has 1 electron. Okay, they have 1 electron. So kalau kita susun, it is in 1s orbital lah. Okay. So we have 1 electron. Fair enough, and we have 4 of the hydrogen. So maksudnya kita ada 3 lah. Tapi kalau you tengok untuk carbon, okay, carbon dia ada 6 electron. So let's susun the 6 electron. So 6 electron, we have 1s, 2s, and 2p. Alright, so carbon ada 6. So kita susun 4, 5, 6. Okay, remember how I cakap is only the valence electron yang involved in bonding. Only valence electron involved in bonding, right? Only valence electron involves in bonding. Okay, dia ada 4 valence electron. Tapi it does not make sense untuk carbon untuk ambil 4 electrons, right? Ataupun untuk share 4 elektron, sebab 2s ni dah perfectly pair. Okay, maksudnya it is already dah complete dah shell dia. So macam mana dia boleh ada 4 bond? Macam mana dia ada 4 bond, 4 elektron yang dia share? Okay, sebab kalau you guys tengok, wouldn't it just share 2, right? So apparently carbon undergoes a process called hybridisation. hybridisation maksudnya is in simple term is diorang campur the orbitals. So where orbital 2s bentuk dia around like this, and 3 orbital untuk 2p tu okay. Kalau korang draw cantik sikit jangan ikuti contoh saya yang buruk ni. Okay, and another one. Oh my god, I think my tangan sengit lah, right? Ish. Okay, so Z, X, Y, Y. So we have this. Apparently, what carbon does untuk accommodate 4 of the hydrogen is dia orang campurkan semua. Dia masukkan dalam blender, dia campur semua, having a sp3 punya hybridisation. Okay, don't worry, akan cerita what is sp3 semua tu. So sp3, it means that dia campur satu s orbital, so and we have 3 p orbitals. Maksudnya dia ada px, pz and py. So dia campur 3 p orbitals, and okay, so dicampur ini and ini and ini and ini. Okay, but other molecules may not campur all 3. Other molecules may only need this much. Okay, contohnya NH3. They only need 3 je orbital. So hybridisation untuk N is sp2 sebab dia ambil satu s orbital and it only require 2 p orbitals. Tak kisahlah px ke pz ke py. Okay, so now when dia dah buat sp3, okay, sp3 akan jadi bentuk macam ni dia punya orbitals. Okay, remember dia ambil 3 kan, 1s, 3p. So this is sp3. So in this sp3, the electrons yang dalam ni dah bercampur semua, dia orang akan susun neatly like this. Okay, hence why, sebab itulah dia boleh berkongsi dia punya electrons dengan 4 H atom. Sebab this H atom yang ada, nak color biru lah, yang ada satu elektron form dia punya 1s tu, dia akan sharekan masuk, so dalam ini, and ini, making it a fully filled orbital. That's how they share electrons. Okay, so hybridisation. So contohlah bila dia dah hybrid, dia punya bentuk most of the time dia akan bentuk macam a p orbital yang cacat sikit, because there's always one bit yang bigger than other. Okay, and usually we call this a different phase, but that's not in the syllabus. Just know that we have 2 phases, so we have the bigger one and the smaller one. So contohnya sp orbital, we only have one s orbital. So s orbital, and from the 3p orbital tu, so kita ada p, we only ambil 1 and 2, so we having sp, so kita campur 2. While kalau untuk sp2, so we have 1s, 1p, and second p orbital kita campur, we have this. So when campur the orbitals, we also produce dia punya molecular shape. Okay, since dia punya orbital dah mix together, hence why kita have a hybrid orbital punya shape. It is very easy dia punya shape. Alright, so kalau SP ada berapa orbital untuk SP yang bercampur? Tolong cakap. Saya tak tahu korang tidur ke tak. SP ada 2. SP ada 2 orbital. So berapa? Saya dah bagi tahu dah ada 2 orbitals. Korang ni lambat sangat. Okay, so SP ada 2 orbitals. So maksudnya dia ada 2 pairs, which means that dia punya shape is linear. Okay, kalau you guys remember, cara kita tengok is linear. So kita ada 2. Kalau dia adalah SP2, which is dia ada 1 S, ada 2 P, dia 3, dia adalah bentuk trigonal planar. Trigonal planar. While kalau it is SP3, so dia ada 1S, dia ada 3P, dia akan bentuk macam tetrahedral. Tetrahedral. That's why kalau you guys tengok tadi, CH4 is shaped as tetrahedral. Okay. Now, what if SP3 and then D and then tak cukup juga? Okay, macam mana yang tak cukup tu? Apa contoh yang tak cukup? Is as contohnya expanded octet. See? Expanded octet. Okay, contohnya phosphorus ni. Okay, dia adalah bentuk trigonal bipyramidal. Okay, so why dia boleh buat jadi bentuk trigonal bipyramidal? Even ada 5, because now instead of guna 1 daripada S, mana my cursor ni? 1 daripada S and 3 daripada P. Now they also ambil daripada D orbitals. 1, 2, 3, 4, 5 D. So dia ambil 1S, dia ambil 3 daripada P ni, and dia also ambil 1 dari D ni. So dia dah mix menjadi sp3 D orbital. Okay, so dia jadi trigonal bipyramidal. And lastly, untuk this syllabus, because kita only belajar sampai shape of octahedral, the maximum yang kita hybridize untuk matriculation punya syllabus is sampai sp3d2. Maksudnya 1 dari S, kita ada 3 daripada P, and kita ambil 2 daripada D orbitals, having a total of 6 electron group, ataupun in other words, they have 6 bonds lah. Okay, untuk dia punya angle, untuk dia punya shape, sama je macam yang kita belajar before this, molecular shape. Okay, untuk this, there's a step by step yang you guys kena follow untuk determines dia punya shape. Okay, the first, you guys need to know dia punya molecular formula. Contoh yang dibagi, saya bagi CH4 lah, contoh lah. So you know, you dah tahu dia punya CH4. Okay, because sometimes question this is cakap methane. Okay, methane tu apa? So CH4. And then you buat dia punya Lewis structure. Okay, Lewis structure, remember, count dia punya valence electron of carbon ada berapa, and then hydrogen ada berapa, and sebabkan dia 4. And then remember, letak the most electropositive dekat tengah, letak dekat tengah with except hydrogen lah. So letak tengah, and then you just susun. Okay, take note that on Lewis structure, you tak perlu nak susun, even though this you dah tahu is tetrahedral. Okay, I know because my student are very smart. You dah tengok pun tahu, this is tetrahedral, right? So, even though that, you tak perlu nak buat shape lagi. Because Lewis structure, one thing yang dia tengok is you punya electron count. So, is it octet? Is this already duplet? So, is it stable? Itu dia tengok. So, that's the Lewis structure. Okay, and then molecular shape. An electron group arrangement is when you nak tengok dia punya orbitals. So you tengok dia punya lone pair, central atom. Sorry, you tengok dia punya central atom. Okay, you buat electronic diagram. Okay, orbital diagrams. So carbon you buat dia ada 6 electrons. So you susun 1s2, 2s2, 2p2. You buat dia punya orbital diagram. Tak cukup lah. Okay. You buat you punya orbital diagram. And now from the orbital diagram.
Carbon bukan 4 kah?
Yeah.
Carbon bukan 4 kah?
Carbon ada 6 kan? Ada 8 ke?
4. Valence ada 4.
Carbon group berapa?
14.
Oh ya, yeah, carbon ada 8. Betul. So dia ada valence 6, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, yang tadi saya salah tadi, yang awal tadi tu. Okay, betul ke saya buat?
Bukan sir, carbon ada 4 valence kan?
Saya pun dah pening ni. Okay. So untuk P, so carbon ada 8, right? Betul kan? Total electrons. Okay.
Ada 6 electrons, carbon 6.
Electrons ada 6. Carbon ada berapa? Korang ni buat saya pening lah.
Total dia 6 tapi
valence
dia 4.
Okay, so carbon ada 6, right? Oxygen yang ada 8, right? So carbon ada 6, so 1, 2, 3, 4. Sini. Okay, so carbon ada 6, right? So nak buat dia nak share electrons, dia tak boleh nak share 2 sebabkan kita perlukan 4. So dia buat hybrid orbitals. Which is dia campurkan 2s and all of the p having 1, 2, 3, 4, which is having sp3 orbitals. And then this thing, all of this are actually the same thing yang you guys buat dalam molecular shape. Because at the end, you guys akan buat dia punya molecular shape jugalah, which is you akan dapat tetrahedral. Dia benda yang sama je, macam molecular shape. It just that hybrids orbital. Okay, hybrid orbital is just a theory yang kita nak explain kenapa dia boleh buat more bonds than dia punya electrons, then bilangan electrons yang unpaired dia ada. Okay, kalau you guys tengok untuk carbon we only have 2 unpaired electrons. So having 2 unpaired electrons, sini ke saya cakap tadi, right? So the bilangan of unpaired electrons does not correspond with the amount of bond yang dia ada. That's why we come up with hybrid orbitals punya theory, right? So, dan contohnya untuk formation of pi bond. Okay, macam mana pula kita nak explain the formation of pi bond? So, besides sp2 hybrid orbitals, okay, we also have p unhybridized orbitals. Okay, maksudnya, okay, contohlah sp2 kan. sp2 maksudnya dia ambil satu dari s and dua dari p kan. So, p. So, dia ambil this and dua dari p, making sp2. Okay. Now we are using hybridization punya teori untuk explain pi bond. Okay. Macam mana pi bond boleh terbentuk. Okay. Since kita guna sp2 untuk bonding, so sp2 kita ada trigonal planar. Kalau you guys nampak ni, bentuk trigonal planar and dia punya angles is 120, right? 120 degrees. How pi bonds form using hybridization theory is, kalau you guys tengok, this orbital still tak diguna. Dia still tak dicampurkan dalam blender yang membuat hybridization ni. So it is still exactly like normal p orbital. Okay, still bentuk p orbitals. Since it is bentuk p orbitals, right? It is bentuk p orbitals. So cara dia punya nak bond, macam tadi saya tunjuk, pi bonds, dia bonds or they overlap side to side. So having a pi bond here, that's how they overlap. Okay, so that's how you explain the pi bond guna hybridization theory. Okay. And then macam mana pula kalau formation of triple bond? Macam mana dia cerita triple bonds? Triple bonds is, kalau you guys tengok, for this carbon ni, you nak tahu dia punya hybridization, okay, it is an sp hybridized bonds. Okay, tolong take note that hybridization, oh tak nak warna merah lah, sikit mata tengok. Okay, hybridization, macam mana saya eja hybrid? I dah lupa cara eja hybrid. Okay, hybridization, alright, only tengok single bond only for sigma bond ataupun yang single bond, which is anything yang bukan pi bond. Okay, pi bond never hybridize. Okay, hybridization is only for pi bond. Okay, the very first bond. So you nak tahu, a simple way untuk nak tahu whether hybridization dia apa is you count dia punya sigma bond. So kalau macam carbon ni, you have one sigma bond, you have two sigma bond, so it is sp2. Okay, kalau it is macam tadi methane, we have one sigma bond, two sigma bond, three sigma bond, four sigma bond. Kalau 4, it is sp3. Alright, sebab kita guna 3 daripada p and 1 dari s. Okay, that's it. Kalau macam hydrogen ni, ada ke di hybridization? Because it's only need one bond, so it's only s bond. Hybridization only occurs kalau we need more than one bond. Okay, so like satu bond is tak ada apa-apa, tak ada hybridization. When dah start 2 bond, kita dah start S dengan P, and then 3 just kita perlukan 1 S, 2 dari P, and 4 kita guna 1 S. S always diguna sebab S punya orbital is the closest to nucleus. Okay, we have 3, 5, sp3. Tapi sekarang kita dah habis p orbital, so kita start guna D, and then kalau tak cukup lagi, kita perlukan 6, kita guna sp3d2. Okay, so berbalik kepada third punya bond, which is a second pi bond. Macam mana nak explain this second pi bond guna hybridisation theory, right? So the first is dia punya hybridisation, which is sp bond, sp bond, sp bond, sp bond. Okay, since we only use, so this is S and this is P, we only use one S and one P orbital. Okay, we have two empty p orbitals. These two empty p orbitals sama je macam saya explain guna model tadi. They overlap tepi and tepi, making it pi bond. So we have one pi bond here and here. Another pi bond is the green one. Okay, the green one. So sama sahaja. It just you are explaining it using hybridization instead of VSEPR theory. Okay, so that's it. Do you have any question pasal the topics? Ada soalan ke? Kalau tak ada, I want to discuss one question from tutorials. Lain dokumen. Everyone okay so far ke untuk this?
Sir, can I ask?
Yeah.
Macam tadi kan, if 5 bonds and 6 bond, dia punya d orbital hanya ada satu atau dua.
Yes.
So, kalau 5 bond, dia akan ada extra 4 empty orbitals kan?
Yes, dia ada 4d orbitals. Yes.
Ya, tapi kenapa tak ada 4, like 4 bonds at one time? Because it have 4 empty orbitals.
Okay. So, let me show you my here documents. Okay, how a bond form, okay, is to share the electrons and to make it pair. Okay, macam mana dia nak form is they share the electrons and make it pair. Okay, contohnya I'll give you oxygen gas. Okay, macam mana oxygen A boleh bergabung dengan oxygen B is they orang share electron. It is covalent bond. How they have bond lah. So these electrons, so kalau kita tengok oxygen have 8 valence, 8 electrons. So kita isi. So oxygen, so we have 1s, 2s and 2p, right? Mana color? So here 1, 2, 3, 4, 5, 6, 7. Okay, how they orang share? Okay, this is they orang are not even using hybridization. Sebab okay, contohnya daripada A, and then we have oxygen from oxygen B also have the same amount of electrons kan? Same amount of electrons. Right? 1s, 2s, 2p. So untuk dia orang completekan dia orang punya orbitals, so dia orang just share this. These are shared together. So actually dia orang punya p orbit, sebab tu dia punya p orbital overlap. Okay, so dia orang overlapkan these p orbitals. Okay, so bayangkan saya ambil ni, saya overlapkan sini, so the two p orbitals are overlap. So here, and this daripada sini dia ter-overlap. So this is how daripada oksigen B. Okay, this is how diorang complete. This is how covalent bonds work. Hybridisation, why we keep using more and more, kenapa kita perlu mix? Because tadi macam yang kita tengok CH4, okay, carbon only have 2 unpaired electrons. Okay, carbon only have 2 unpaired electron dekat here. Right? Tapi dia perlukan, dia buat bond dengan 4 hidrogen. So macam mana dia nak buat bond even kalau dia only have 2? That's why we took account of the 2s. Okay, kita pecahkan dia orang ni masuk satu-satu, kita campur dia menjadi hybrid orbital, which is sp3. Okay, that's why dia punya orbital sekarang every electrons are singly filled. Then baru kita boleh ambil 1 electron each from hydrogen untuk pairkan. So an example of kalau d orbitals, alright, how d orbitals work, we mostly expanded octet. Okay, contohnya sp3d2, okay, which is bentuk dia octahedral. Okay, so we have one example of this. So let me tengok, it is as phosphorus chloride. So let's take phosphorus chloride 5. It is sp3d. Okay, phosphorus chloride is one example of sp3d. Macam mana dia dah ambil in d orbitals. So phosphorus, dia ada berapa punya electrons? Dia ada 15 electrons. So phosphorus ada 15 electrons. Let's fill in. Okay, 1s, 2s, 2p, and then 3s, 3p. So we have dekat sini. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so let me draw the boxes. Alright, so untuk phosphorus, it only has 3 unpaired electrons. So we only have 3. Tapi you guys tengok, dia buat 5 bond. So dia ada, phosphorus ni ada 5 bond dengan chlorine kan. So mana dia nak cari lagi this chlorine, chlorine, chlorine and chlorine. Mana dia nak cari lagi 2 unpaired electrons. So apa yang dia buat is dia dah start ambil d orbitals. So even though kalau you guys susun 3p lepas 3p ni 4s kan, betul tak? Kan? But in hybridization, we take a look on dia punya principal quantum number. Okay, we have 4s, we have exactly we have 4s. We also have 3d. Okay, even though tak ada electrons, but the orbitals are there, are always there. Okay, kenapa kita ambil 3d instead of 4s? Okay, even though 4s dia punya energy is rendah, that's only, so take note, untuk 4s rendah pun 3d, that's only for Aufbach punya principle where kita fill in electrons. But in quantum mechanics, once the electron ada enough energy untuk masuk 3 punya quantum number, dia punya shell 3, dia ada access on every available orbital yang dalam n equal to 3. So that's why untuk P, phosphorus, dia ada access untuk 3d tapi dia tak ada access untuk 4s. Okay, sebab electrons di only ada available sampai n equal to 3. Okay. Kalau kita ada more electrons, more energy, barulah kita boleh access 4s. Even though 3D is higher energy, these electrons are able to access sebab dia punya principal quantum number sama. So, dia ambil the 3D orbitals. Okay, dia ada 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, tergarak habis. So, untuk having 5 unpaired electrons, so, kita already ada 3. Kita ambil lah sini. 1, 2. So, campurkan. Kenapa dia tak campurkan? Kenapa dia also kena campurkan dengan 3s? Sebab, kalau you guys tengok, dicampurkan 1 dari S, 3 dari P, and 1 dari D. Barulah kita dapat 5. Okay? 1, 2, 3, 4, 5. And you punya, tadi the question is, dia ada 5 kan? Contohnya ada 5 bonds. Kenapa this electron just tak dikongsi dalam the empty d orbitals? Like D ada 5, right? Kenapa tak kongsi je? Sebab to make a bond, to make a covalent bond especially, covalent bond, okay, the main thing is we share electron. So, to share electron, the basic thing is kita pairkan electron. So, untuk pairkan electrons, kita only have 3 singly paired, so we need 5. So, kita ambillah 1 dari sini, kita ambil yang ini, and also 1 orbital dari sini, making it a 5. Okay? How you explain it is, you tengok berapa banyak bond dia ada. So, hybridisation theory is, kita tengok berapa banyak bond dia ada. We are trying to rationalize how dia boleh buat banyak bond tu. So, tengok those bond. So, dia ada buat 5 bond. So, it means that dia ada 5 singly paired electrons. The central atom. That's why dia boleh buat 5 bonds. Kalau kita susun ikut biasa, it does not make any sense. Kalau dia kalau dekat 3D barulah dia, kalau dia ada electron in half field 3D baru dia boleh buat kan. Tapi dia tak ada. Macam dia boleh buat? So, that's how we explain lah. That the orbitals are mixed together, rojak-rojakkan dia, goyang-goyangkan dia, and kita dapatkan 5 orbitals yang same energy regardless. Okay, does that answer your question? Okay ke?
Yes sir, but I have one more question.
Okay.
Because looking at this now kan, it has 4 unhybridized orbitals.
Okay.
So adakah dia akan ada 4 pi bond at one time? Because the most we learn is triple bond.
So, dia ada 4 unhybridized orbital kan, kosong. Dia orang only will create a pi bond kalau it needs to. Alright? Most likely, untuk kalau D, dia orang tak buat pi bond. Sebab, kalau you tengok, untuk P, it is already an expanded octet. Right? Most of the atom, dia orang dah happy dengan 8. Okay, 8. But this P, dia ada 10 valence electron keliling dia. Alright? So, dia dah tak perlu dah. Ibarat you dah kaya, so you dah macam tak perlu dah nak cari more duit. Okay? Dia dah ada banyak valence electron, dia dah tak perlu dah. Okay? It is happy dengan expanded octet. Alright? The valence, the one yang empty orbitals yang buat pi bond tu, usually dalam oxygen, dalam carbon. The reason is sebab dia tak cukup lagi octet. Okay? So, macam contoh carbon dioxide. Okay? The reason dia buat pi bond is because kalau carbon sini, dia carbon masih tak cukup. And carbon kalau boleh, dia memang suka nak octet. Okay. So, dia macam ni lah. So yang kalau dah expanded octet tu dah macam golongan T20. So golongan kaya. Diorang tak perlu dah nak cari duit. Nak buatkan double bond. Orang yang buat double bond ni is golongan yang macam kita ni. So rendah ni, golongan marhai ni. So then kalau baru diorang buat double bonds. It is possible untuk those 3D untuk buat pi bond, tapi dia tak perlu. So dia tak buat. Okay? Faham ke?
Yeah, faham sir, thank you.
Okay. So anyone have any more questions? Ada question ke? Kalau tak ada,